Greetings, this is Artie from Artifact Electronics. Today we're going to have a look at my absolute latest acquisition, something that I've been looking for a while. And what this is a Moog Sonic 6 synthesizer. It's a portable instrument. It is housed in an ABS plastic case. Close it up, latch it, and you carry it to your next gig. It's a really interesting instrument. Gives you a lot of functions, and some of the less traditional functions that these synthesizers had, and it has its own output speaker. Even though that doesn't really do it any justice, in a pinch all you got to do is find an AC outlet and you can play it. This was mostly used for educational and demonstration purposes, but it is still a Moog. There was some drama surrounding the design of this instrument. This was designed originally not at Moog, by an ex-Moog employee. But what they did, it wasn't this instrument particularly, but its forerunner, which was called the Sonic 6 and looked like this. More traditional with wooden sides, non-portable. But if you compare this to the control panel is almost identical. Some of the extra controls on the sides are different, but all of the buttons and the flow of the sound was pretty much the same. And what happened here, another company designed and built this, and then they couldn't sell it, because at the time people were already brand conscious, I guess. So after some drama and card shuffling and horse trading and all of that, the design ended up at Moog. And Moog looked at this, took the guts, put them into an ABS plastic case, made a few relatively minor changes, more of a nature of performance and output, and created an instrument that I think hit the market in 1972 and lasted until 1979. It wasn't one of their more popular devices. Obviously, the Mini Moog comes to mind, who far outsold this, but I think this sold 6,000 or 7,000 units on its own, and it's a really interesting instrument. Here's one of the original listing pictures. It kind of looked a little bit nicer than it actually was, but by now, if you're buying stuff online, you should be used to that. Digital cameras do that. The note, though, that on the lower left and upper left, see how rusted those hinges look? Well, obviously I've got them cleaned up already because I can't stand dirt. Some people won't clean up a new acquisition until they are sure that they can fix it, so they don't waste time. But on this guy, I'm going to fix it. So I already started cleaning it up, getting dust and stuff like that off of it. I got it for a really good price. Relatively much less than what a working one or others are being asked for. But again, that's a relative price. The absolute price was still kind of heavy for something that's 45 years old. But I think it was worth it, especially if you can get it back into full working order. This was advertised to be in poor shape. Well, not physically. Physically it's pretty good. I used to have another one of these years ago, and I fixed it. It worked, but I could not hold on to it because, this is an ABS case, but it looked like it had been dragged behind a railway car or something, and the instruments I keep need to look somewhat nice. Anyway, since I sold the other one, you know, I always regretted selling it because it sounded so interesting. But another one has come in, and it looks nice. But unfortunately, the comment of it's in poor shape refers to its functional status. It comes on, as you can see, with the power light on, but it is set to the internal speaker right now, and it doesn't make any noise. When I crank up the volumes full blast, I can hear a tiny bit of hiss and a drone, a note that is just playing consistently in the background. I can't change the note by pressing a key. So it also has monitor outputs. So you can turn off the internal speaker and turn off a monitor, or you know, whatever combination you prefer. And when I hooked it up to that, I pretty much got the same, except there was a little bit more volume, a droning voice, and that the keyboards didn't seem to affect. Some of the controls worked, others didn't. It didn't make a whole lot of sense to me. So the bottom line is, I will fix this. And the reason I'm being so confident about that is, this is an old instrument. There is no microprocessor in here. There are no ROMs or EPROMs in here, which in a newer one or in something that has an EPROM, and the EPROM's bad and you can't get an image of it, you're basically done for. This does not have anything that specialized like code. It does have a few parts that are a bit dicey to replace or expensive to replace, but the bottom line is pretty much everything in here can still be gotten and replaced. So let's go ahead and have a look on how we're going to attack the repair of this guy. I do have a user manual I downloaded, which walks you through how to create sounds, but that we'll get to later. I also have an original copy of the service manual, which I also got a few years ago. And usually the first order of business is to check the power supply. So let's have a quick look in here and figure out what we should be looking at. So what we have here is a schematic of the board that sits to the left of the actual keyboard. And nothing great going on here, but we've got a transformer feeding a full wave bridge, smoothing caps. So ground is basically tied to earth ground. And that's the chassis. So the whole thing is grounded to the earth on the AC outlet, and that is maintained as ground. Because normally when you have a full wave bridge rectifier and you're only using the positive leg, they ground the negative leg. But I'm sorry, if you use this is the positive leg and this is the negative leg, but both legs are being used because this shows that you have plus and minus unregulated DC coming out of it. Look a little, there's two grounds. If you look a little bit further, it says plus minus 15 volts regulated, but those are obviously not done on this board, but rather it sends the unregulated off to the boards that are behind the panel, and they regulate and send this back, which is then even used here because it's got a pitch bender on it, and I guess certain things that do use the or need the regulated plus minus 15. But let's have a look at what this looks like physically and see if we're getting anything out of here. So I removed the screws of the plastic part covering the keyboard. We'll just shift that up. And to properly follow safety, I will unplug it. And so here you go. What we have here, we have power coming in here, and that's kind of interesting because if you look at it closely, remember there's a tray over here, a rectangular tray above the keyboard on this, and I saw some pictures where there was basically a power cord lying in here. However, this has a permanently attached power cord, which is here. And if we look at these connectors here, it's got these red butt connectors, which are probably factory. But these don't look factory because they're completely different from the red ones. And it looks like somewhere along the line, somebody came along and decided to remove. It must have had a plug here, an AC plug, but for some reason that was replaced. I really can't tell if this is factory or not, but what seems to be a dead giveaway is, look at the plate that's holding the power cord in place. It looks like a piece of proto board. So I'm not sure why that was replaced or why somebody would do something like that. Because especially, you can't, it's not that portable anymore. You can't shove the power cord all the way in. It won't. It'll go in part way, but, it'll take quite some calisthenics to push it all in. And then, of course, the plug will still be sitting outside. So I really don't know. What I was planning on doing is fixing that, basically see if I can replace this part with just an IEC socket, and then just use a regular IEC cord that could go into here. Okay, I lifted the circuit board, which is called circuit board number 3, and we see we have 2 computer grade caps here. I have a common ground and then plus or minus, I don't know which is which, but that's the unregulated voltage, smooth unregulated voltage. So let's have a look and see what these output. Now my guess is, since we're generating 15 volts, or regulating 15 volts, it'll probably be somewhere around the low 20s, what we should be expecting out of here. And turning on the power strip. I did hear a buzz coming out of the speaker, but if we measure the left side cap, we're getting minus 24. Let's call it minus 25. And the right side cap is plus 24. Bit asymmetrical, but it shouldn't really cause any problems because I guess for the oscillators and stuff, it'll be using the regulated voltage, which we can test and see on the board. And just for grins, let's have a look at the AC. So we're looking at about 370 millivolts. It's not good. I think that may indicate the capacitors are getting a bit tired, and they probably need to be replaced. And the other side says (1 volt AC. So that's kind of high. Those are 2200 microfarad caps. That should be lower. I think the 300 on this side was more characteristic. So one thing that definitely needs to be done is we need new caps here, but not right now. Let's follow the voltage to the boards behind the panel, see if we can figure out if everything's going okay back there. So I loosened the control panel and laid it on top of the keyboard because it's got this big connector right in the middle here where we got the connection to the power supply, and it's going out to the to all the jacks that are accessible from the front, and the accessory jack and all of that. And I figured, let's see if the voltage is coming in. And if you want to have a look at this, can you kind of see that? Yeah, you can kind of see that. It's using a pair of 723 regulators. It's pretty simple. You got your ground pins over here. Can you see those? No, can't see those. We got the ground pins coming in from that big connector I just showed you. We get the unregulated going in. This is the minus unregulated. Yes, the minus unregulated coming in. The chip regulates it. It's just a 14-pin chip, so it can't handle a lot of current. So they usually got a pass transistors to allow for larger current flow. And same thing on the positive side, even though the configuration of the pass transistor is minimized here. So the way this works is the unregulated comes in, the negative unregulated comes in on A7 and leaves on A5. The positive unregulated comes on A6, that's the connector, and leaves on A4. And as I was taking things apart, I was just looking at it. It's insulated because I got this bubble wrap, which isn't, even though it's blue, it is non-conductive laying here. So I turned the machine on, had a look at this connector over here, which is held in place with two small screws. And I started measuring voltages, see if the unregulated came in over here, and it gets regulated. The regulators sit under here. They're these two. And as I was starting to probe it and get the camera angle right and everything, and as I did that, as I started touching the power pins, all of a sudden the synth started emitting sound. And since I was still setting up the camera, I wasn't running, so you're going to have to take my word for it. But as I was probing the pins over here, I noticed that when I let go, when I didn't measure anymore, the sound went away, because when you pressed on this, I must have pressed some keys down, and it sounded like it started to do something. So the next thing to do is, or was, for me to look at this connector, which I have loosened. And again, since it is off now, and since I was just noodling around and I didn't film it, I just pulled the connector out. And what it seemed like at the time was there was an intermittent contact where the unregulated positive voltage was coming in somewheres over here, but when I measured the plus 15 out, there was nothing there. So I said, okay, we got a bad voltage regulator. I started measuring on the board, and lo and behold, the voltage regulator, the unregulated voltage, wasn't coming in. So there really wasn't a whole lot to look at, because essentially on the pin I could read the unregulated positive voltage, but it wasn't making it into the voltage regulator. So what I did, and see, at that point I got excited, that's why I didn't stop and pay attention. It looks like these pins are a bit corroded. So I started cleaning them with alcohol and a Q-tip. I then reinserted them. You got to be real careful, because this is like a really old style connector the way they did it. It's actually very possible to plug it in wrong, at which point you'd be creating a lot of damage. But once I plugged it in, it seemed as if now all of a sudden the plus minus 15 volts was there. So what I blame it on is that the pins, I mean, I checked the solder connections and they look good. I did reflow them eventually, but they look good. There was nothing wrong with them. The pins also look good, but there was something on there because after cleaning it with alcohol, the positive voltage came back to life and it was doing something. And that would actually make perfect sense. If the positive voltage is missing, nothing's going to work. I mean, most of the things in here expect either a positive voltage regulated or a bipolar voltage, plus minus 15. And if the plus 15 is missing, it's just not going to work. And we can also peek over there. There's an integrated power amp that it's using. That guy over there. And those usually run off of positive voltage only. I can verify that looking at the schematics, but obviously if there was no positive, no plus 5 volts coming in here, then this would have been quiet too. So I think we just went a far way towards having fixed this thing. But let's put the panel back up and see how it performs. All right, let's see. Let's turn all the volumes down here. And as you can see, I'm missing some of the slider knobs. This, and this. These two are still there, but back here there's 2 slider knobs missing. And but other than that, it seems complete. None of the buttons are missing. None of these slide switches are usually the first thing you lose, and it's got all the slide switches on it. Covers, I mean. So it looks good. So let's see what it does now. So I got the buzz out of the amp again, which I don't fully understand how that thing would buzz. It must be driven off plus minus 15, but so if we move the volume up, we have a speaker, internal speaker on, and we hear nothing, so well, it's doing something. Okay, let's shut off the modulator here. Looks like it's working. Okay, why? Oh. Okay, so these are labeled direct output mixer, and I think what that means is it doesn't care. It just routes the oscillators both to the output. That's why it's on all the time. But it wasn't droning. The keyboard was actually changing the pitch. Oh, okay. So now we enable the keyboard trigger. Set to oscillator A. It's got a sawtooth, triangle. Yeah, the speaker is not very... So that's a square wave, and we can change the duty cycle. Speaker is buzzing a bit, but it looks like it's working. So then we turn the balance to B. And then this is how we balance the two oscillators against each other. So if I put it in the middle, we should get equal output from both of them. Yeah, hear the beat? They're tuned close to each other, but not exactly. So here they're tuned almost exactly, and then you slightly detune them. Yeah, that speaker isn't very good, but it looks like the loss of the plus 15 volts regulated was what was causing the whole problem. It seems to be working. Yeah, and the tuning of the two oscillators, obviously, over here they're pretty close, playing in unison, but when you go up here, you can hear that they're beating pretty quickly. So we're going to have to tune the oscillators in here, the offset and the scale, so they both track as evenly as possible. One of the big complaints about this instrument is that, oh, it's good for making sound effects and stuff like that because it doesn't musically track the keyboard right. But I think that's just because it isn't adjusted. It isn't the voltages, the control voltages. Keep in mind that the keyboard generates precision analog voltages for each key, and the oscillators need to be tuned properly so they track the keyboard equally. And that's all we're hearing here. This thing is working. It's got the self-oscillating filter in it, and other things we can mix in. Right now we only have the oscillators turned on in the mixer, but it's got a ring modulator, and so in a ring modulator, you take two audio inputs and the outputs are both the sum and difference of the incoming sounds, and it becomes non-musical very quickly, but you can get some neat effects out of it. The next mixer setting is external input. You can run all sorts of other things through here and filter them. We have nothing, so we're not going to hear anything yet, but and then of course there is noise. White and pink noise. Looks like that's what it was. It needs a tuning, it needs adjustment, and it needs some more cleaning, but looks like we got it. Next, I decided to take care of some of the other issues we ran across. First one was to replace the fixed power cord with a removable IEC plug. It wasn't too bad. I had to take out the whole bottom, take out the old garbage, and basically put an IEC jack in there. It wasn't too bad because the mounting holes matched up exactly. So I think that goes along to prove that there was an IEC cord in there originally, but for some reason they decided to put a fixed cord in there. And it needed some new wires and wire nuts, and that got done. Next we got to come to the capacitors, which are underneath here. I have them removed, and this is what the originals look like. And the nice thing was is they have the screw terminals, and once they were in their clamps, you could just screw on the connectors to them, the eyelets, and didn't have to modify the inner wires at all if I got direct replacements. But I can't find any of these, the computer grade screw terminal ones. 2200 microfarads at, I think these are rated at 40 volts. Now, it was easy enough to find replacement capacitors. I got 2 of these, and they are Nichicons at 2200 mics and rated at 63 volts. But you know, putting these in as they are, it's kind of messy. I could zip tie them to the clamps and then fly wire them to the existing connections, and it would be really ugly. So here's what I decided to do. I decided to reuse the cap cases and basically rip out everything that was inside of them, which consisted of the capacitor itself and a lot of black goo, some of which you can see there. And then those were kind of welded to the contacts, like this contact here, to the reverse side of the screw terminals. But try as I might, I could not, I mean, the old cap would fit in there, especially since I cleaned out the goo, but I couldn't solder to the terminals, the screw terminals. They were originally welded, and no amount of flux or steel wool or solder guns I could not get any solder on there. So I was unable to connect the capacitor from the inside. So what I ended up doing was I hot glued the capacitor into the end cap, drilled 2 holes, that's obscured, but basically ran the leads through 2 holes in the cap and brought them out the other end. And then I could just loop them and put them on the terminals. But no, the leads were too short. So I had to get some. What I did was I got some heavy-duty leads off of a resistor, made a loop, and then soldered them to the wires, the capacitor wires that were peeking through. And then once all of that is done, this gets stuck in the case. I tape it or glue it back together, and the nice thing is we can put these back into the clamps and attach the terminals, the original terminals, to it, screw them in, and we kind of maintain the look, and we have a stable capacitor assembly in here. So let me go ahead and do the other capacitor. And by the way, I didn't mention both capacitors the old ones were shot. They had drifted way out of range, and also the ESR was pretty high on them. So this does necessarily need new capacitors, and I think this solution should work just fine. So the cap stuff took a little bit longer than I hoped it would take, but it was the right approach to take, because I hot glued them back together and put a piece of tape over the seams. But basically the wires and the screws fit on just like they were before, and it's much neater and much more secure. And after measuring the voltages, I now get plus minus 25.5 volts with a ripple of approximately 150 millivolts on each side. So it definitely needed the caps, and it's going to make tuning the oscillators a lot easier. And, well, not necessarily easier, but they are going to remain much more stable with a better source of unregulated DC voltage coming in. Okay, so I reassembled the bottom part, and that still works. It comes on. The instrument still plays, but it definitely needs some adjustment. But we're getting a little bit long on this video, so I think I'll stop this episode here. And in the next episode, we'll go and try to do some adjustments as pointed out in the service manual and see if we can get it back to full working condition. Thanks for watching. Hope you enjoyed it. Leave me a thumbs up if you want, and even if you don't want. Especially for one of the speediest general repairs for a dead instrument, and it generally, when you have a dead instrument, it's usually the power supply. In this case, of course, we saw the power light come on, so it seemed as if it wasn't the supply, but I guess now that we get unregulated DC power to the main boards in the back, it's mostly working, and next time we'll see if we can tweak her. And make sure to subscribe too. See you next time.